Hey guys, today we're going to talk about something called density. Before we get into that, we're going to have to review two concepts from the first unit. Concept number one is, wait for it, volume. Here's what I want you to do. Take a look and answer the question. The question is, which volume would be more difficult to measure? Okay, now go ahead and answer the question, which mass do you think would be more difficult to measure? Cool. So here's the deal. In both of these cases here, I would probably say that the bear might be a little bit more difficult to measure. Definitely for volume, we would say. This block has a nice 3D shape where we can easily measure one side with a ruler, another side with a ruler, and then a third side with the ruler. With the bear, there's a little bit more than just those three sides. They're kind of all over the place. So probably using a ruler to measure the bear would be out of the question, we would say. And then for the mass, you could probably put both on a scale. So pretty much they'd both be fairly even. So a couple of things that we should know. Volume, you can measure it in 3 dimensions with a ruler, or you can measure it by something called water displacement. In that measurement lab, there were a couple questions about water displacement. So hopefully you remember. If not, we're going to show you how we do it again. And then for mass, how do you measure it? You measure it with a balance. You just kind of put it on a scale, and then it'll give you a reading. Sometimes you'll have to use a physical balance and actually move weights around. Sometimes you'll get to use an electronic balance where it does that all for you, and it just tells you the number. Keep in mind, weight is measured using a scale, so we usually call things that measure mass a balance. Weight and mass are fairly the same thing, pretty similar to the same thing here on Earth. Mass is measured balance-wise, and weight is measured with a scale, is kind of the difference. But weight and mass do have different terms, so there are different ways to measure them. Okay, so how do you find the volume of this box? It's 20 centimeters by 20 centimeters by 10 centimeters. Hopefully you know from this that you just multiply these three numbers together to find volume. Volume is, of course, length times width times height. When you do that, you're going to get 10 times 10 times 20, which gives you 2,000. And then the units for that are just centimeters times centimeters times centimeters, which is the same thing as centimeters to the third power, or centimeters cubed. So, important to know, volume is length times width times height. Also important to know that the units for volume are centimeters cubed. So please make sure you have this formula for volume written down, and you know the unit for volume is centimeters cubed. Awesome. Next question, we have a quick volume lab here for you. We would do this in school, but you're just going to kind of walk through this with me here. Okay, so here's the first picture. We've got this golden cylinder that we're trying to weigh. We've already filled the graduated cylinder up with 50 milliliters of water. To figure out how much volume this golden cylinder has, what we do is, instead of measuring it using a ruler, we just drop it right into the water. And then what you'll notice here is that the water level from picture 1 to picture 2, it's risen a little bit, and now it measures 60 milliliters. So the only thing we added was that golden vial, so we would say that this volume is 10 milliliters. This process here is called volume by displacement. So that's how we find the volume. We put something in and it displaces the water to give us a new water level, which tells us how much volume the little vial, the little golden tube here had. Okay, so here's a question. We got a dead tree over here, and we've got just a regular old duck. Which one do you think would be heavier? Hopefully you'd say the tree. Now the question is, why do they both float in water? That's the question for you. Why do they both float in water? In case you didn't know, it has to do with something called density. So we're going to talk about density in a little bit. We're going to talk about what it means, but for now what you need to know is, remember, mass is measured in grams, and volume can be measured in cubic centimeters, cm cubed, or it could be measured in milliliters. And the important thing here is cm cubed is the same thing as 1 milliliter. Those are equal numbers to each other. So sometimes we'll use milliliters, sometimes we'll use cubic centimeters. those two numbers add up to the same thing. So yeah. Now, density is mass divided by volume. So when we're talking about things floating in the water, we're not just looking at their mass, we're also looking at how their mass is compared to their volume. So a tree is heavier than a duck, but a tree has a lot of other tree volume that a duck doesn't have. So not only does it weigh more, but it's also way bigger than a duck is as well. So when we're figuring out the density, that's what's going to tell us if something floats in water. If something has a density that's greater than 1, it'll float in water. If it's less than 1, it will not float in water. The density of water, as you might know, is 1 gram per milliliter. So how we figure out density is we're going to be given a mass, we're going to be given a volume, we plug those in, and then we divide those two numbers by each other. How I remember that density equals mass divided by volume is, maybe you can see this here, let me just get out my pen, is that it's kind of like you've drawn a heart. Here's my M, here's my V, and that kind of looks like a heart that you draw a line through. So I always think of density as the same thing as D equals a heart. There's my beautiful heart with a line through it, and that's kind of like mass divided by volume there. So hopefully that makes sense. Hopefully that's a helpful way to remember it. If not, you don't have to remember it, but it could help. Then the important thing to remember is we're going to use the units, grams divided by milliliters, or we'll just write it like this, G/ml. Those are our units because mass is always grams, volume is always milliliters. So our units for density are just going to be grams divided by milliliters, or gram/ml. Cool. So why do they both float in water? Well, a duck has a mass of like 500 grams, but it might have a volume of 700 milliliters. A tree has a mass, we could say maybe 90 kilograms or 90,000 grams, and it has a volume of 100,000 milliliters. So in both these cases, if we do the density here, 500 divided by 700 gives us 0.71, which is less than the density of water. The tree's density would be 0.90, which again, less than the density of water. So both of these float in water, not because they're light enough, but because they have a low density. Objects greater than 1 gram per milliliter over here, those objects will sink in water. Objects less than 1 gram per milliliter, those objects will float in water. This is also true with oil. Oil has a totally different density. I think it's like 0.8 or something around there. Anyway, so anything less than 0.8 would float in water. Like for example, a duck might still float in might float in oil, but a tree might sink in oil, for example. So yeah, whatever the density of the object is, if it's less than that, it'll float. If it's greater, it'll sink. So both the duck and the tree in this case would float on the water. Cool. Density is measured in as D equals M divided by V. The units are grams per milliliter, or sometimes we might write it as grams per centimeter cubed if we're using centimeter cubed as our volume. So here could be a problem that we might ask you with the volume of a cube, and you would just multiply 10 by 10 by 10 to get 1,000 centimeters cubed. And then we might add something like, if it has a mass of 10,000 grams, what would the density of the box be? Why don't you guys take a moment, go ahead and see if you can't solve that problem. What would the density of this box be? Density equals mass divided by volume, so hopefully you figured it out. You take the mass of 10,000 and you're going to divide that by 100 or 1,000. So our mass is 10K and our volume is 1,000. So 10,000 divided by 1,000, we're just going to get 10 grams per centimeters cubed. In this case, centimeters cubed, since we started with a volume measurement. Cool. Hopefully that helped you understand what density is and how to use it. Expect more density problems in the future. Thanks for watching, guys, and have a great rest of your day.